Good afternoon. Today I will presenting our group's project on the application of numerical differentiation to analyze monthly temperature data from two cities, which is Ipoh and Alor Setar. We used the Papadakis climate classification system as a basis, which focuses on temperature and offer climate variables for agricultural potential. The aim was to calculate the first and second derivatives of temperature data to understand the rate of temperature change and curvature, which can help in identifying warming trend or seasonal transition. We applied finite difference methods, including 2-point, 3-point and 5-point formula, and compared manual calculations with MATLAB simulations to verify accuracy. To start, we manually calculated the first derivatives using several finite difference methods. The 2-point forward and backward estimate the change using two neighboring values. The 3-point methods after better accuracy using more data, and the data 5-point central difference is used as our references method due to its high accuracy. In March for Ipoh, we calculated all values and found the 5-point method gave a value of around -0.3583, while the others had small differences from it. We also computed the absolute error, which is the difference between each method and the 5-point references. This helps us evaluate which methods are more accurate. The same process was repeated for the second derivative, which tells us about the temperature curvature, whether it's increasing or decreasing at an accelerating rate.
So in order to do a numerical differentiation on month temperature data for Ipoh, the following MATLAB scripted was created. The first and second derivative are calculated using finite difference technique, and the quality of these techniques is assessed by comparing the absolute error. So the initialization and data input, this section clears the workspace and defines the data input. The array T stores average monthly temperature for Ipoh, and months hold their corresponding month name. The variable N store is the number of data point, which is the month, and H equal to 1 is indicate equal time spacing between data points. So pre-allocation arrays, first derivative, second derivative, and absolute error values are stored in arrays that are pre-allocated with NaN, which is represent not a number in MATLAB. Pre-allocating prevent indexing problem during loop operation and increase code efficiency. So the next one is derivative computation loops. The first derivative using 6 method, which is 2-point forward, backward, 3-point forward and backward, central, and 5-point central used as a reference value. So the second derivative is using 3-point and 5-point central methods. Each formula is only applied where sufficient data points are available to avoid indexing error near array boundaries. So the next one is absolute error calculation. This loop computes the absolute error of each method by comparing it with the most accurate method, which is 5-point central differences. These allow evaluation of how close each approximation is to the reference.
Better be a written apology. See this? Oh, look how big you are. Oh, this is very nice. We gotta get this framed.
For the first derivative comparison, the result obtained from manual calculation and MATLAB simulation are identical for all methods evaluated. data indicated that the numerical differentiation formula for improvement correctly both manually and in code. The value from the 2-point forward and backward method as well as the 3-point and 5-point central methods are consistent between both approaches. The 5-point central method was selected as the reference due to its higher accuracy and broader data census, which has minimized approximate error. In general, center different methods, especially those using more data points, demonstrate superior accuracy in estimate range of trends. For the second derivative comparison, both manual and MATLAB method again produce matching results, confirming the consistency of the calculation. The 5-point central method serves as the reference method due to its ability to more accurately capture curvature of acceleration within the data trend. While the 3-point central method shows slight deviation, the error remains within acceptable limit, further highlighting the advantage of higher order method in producing more precise estimate. Overall, the cost agreement between manual and MATLAB results strengthen confidence in the correctness of the implementation. MATLAB appears to be a reliable and accurate tool for performing numerical differentiation, making it well suitable for real-world data analysis application.
So in conclusion, this project explores how we use numerical methods to study climate trends using real temperature data for Alaska and Ipoh. We apply different techniques like backward, forward, backward, and central differential method to estimate how temperature changes over time. By doing manual calculation and using MATLAB, we confirm that our results are well accurate and consistent. MATLAB helps us handle large data and create clear graphs to see trends better. We also compare different methods and found that more advanced techniques like 5-4 central method give better accuracy, especially in the middle of the data. In the end, we achieve our goal to calculate and understand temperature trends using math and technology. This shows numerical tools can help solve real-world environment problems.